Okay, year 11 triple. I wasn't really happy last time when I taught SUVAT. That is where you have to find either distance, the initial velocity, final velocity, the acceleration, or the time. So I'm going to go over it again, but I'm going to break it down. I'm going to try and simplify it in this video, in this lesson. So by the end of this lesson, you should be able to understand how we can use this equation or these set of equations to complete all acceleration questions. And you need to do that, you need to identify the known problems, identify the unknown, and then just select the correct equation, which is the difficult bit. So the bit I want to do in this lesson is to just run you through each equation separately. Okay? So the equations that we're going to be using, there are 5, but only 4 are given to you because this one requires a quadratic equation, which is A level. Okay, so we don't have to worry about the 5th one. So we're going to be dealing with 4. These are going to be given to you in your exam in the front on page 2. So you don't need to remember them, but you do need to know how to use them, and we do need to rearrange these sometimes. So just a quick reminder, S or X, as you will see X in your exam. But I'm going to stick with S because I just think it's a really good way to learn it. So S is displacement, so meters, kilometers, etc. U is your initial velocity, meters per second. V is your final velocity, meters per second again. Your accelerations, all these should be, that should be lowercase as well. Acceleration, meters per second, and you'll see me write that a little bit better. This is because it was done on a computer. And then it would be lowercase t for time there, which is in seconds, minutes, hours. We often use it in seconds, okay? So, a bit of a success criteria. I always write my letters. I would write them like this, SUVAT, and then I would start filling in my known quantities. So it says here, fill in the known quantities that you know, put a mark beside them, identify 3 things you know, and 1 thing that you don't, or the thing that you're looking for, and then you would select the equation. But for today's lesson, I'm going to be giving you the equations. That's what I want to do, and then in future lessons, then we can start deciding. Okay, I think that was the biggest mistake I made, was to let you loose on all 4 equations. So I've learnt from my mistakes, so I'm going to do each equation as we come across it. So let's start that. So we're going to do rule 1. This, in my opinion, is the easiest one to use. So we got a final velocity equals initial velocity plus AT, and we've got what these things mean here. Okay. So here's your first example. I'm going to do the first example for you, and then to make the video shorter, I'm just going to give you a chance to have a go, and then I'll show the answers. And then along the ways, there'll be questions that I'd like you to submit on Teams. So the first one, a car starts from rest. So if it's starting from rest and accelerates at 2 meters per second, so that's acceleration for 10 seconds. So the first thing I'm going to do is I'm going to write down my known values. I'm always going to put SUVAT. And this is what I'd recommend you do. Get a bit of paper now and do it with me. Okay? So there's not going to be any S here, okay? So we can kind of ignore S because it's not even in the equation. So we're looking, a car starts from rest, so the initial velocity is 0 meters per second. If anything's rest or it comes to rest, it's going to be 0 meters per second. It accelerates now at 2 meters per second. So your acceleration is 2 meters per second squared because it's per second. It's an acceleration. And it's going to do that for 10 seconds. So my time is 10. Now I've got 1, 2, 3 values that I know. 1 is unknown. So I can put either a question mark or an X. It's up to you. And now I'm going to solve. So I'm going to use my equation. V equals U plus AT. Again, I would like it written out like this. Especially if the examiner knows exactly what you're doing, okay? Now, in this case, we're solving for V, which is handy, really, because V is on this side of the equation. So no rearranging required. V equals U, well, my U is 0, right? My initial velocity is 0, plus A. My A is 2, and my T is 10. So it's 2 times 10. A nice bit of an equation here. I don't need a calculator for this one, although I would still probably use one in an exam just to check myself. But I mean, that is 2 times 10 is 20, isn't it? And that's going to be, because it's initial velocity, and so velocity is going to be meters per second. So that's that one done there. And then I've done it just in case. Okay. So example 2 now, I would like you to actually have a go at this on your own before looking at the answer. Now you could just skip through the video and think, well, I've watched it and I'll just do what I need to. But like anything, if you want to get better at something, you need to put the work in. And there's a reason you're on the triple course. I'm sure you want to do well. And if, you know, the practice is going to help you. It's like trying to get fit without doing the exercise. You're just cheating yourself. And I know it's quite a cliche thing to say, but you need to do them. So I really recommend that you do these examples and then look at the answers, okay? So an aircraft was traveling at the speed of 60 meters per second. And I'm sure you can read the question. Again, just put your SUVAT down and fill in what you know. Have a go. Press pause, have a go. Okay, so example 2, this is what I've got. I had my initial velocity of 60. I had a final velocity because it comes to rest. It takes the aircraft to stop. I got an acceleration there, deceleration actually, because it's a minus. And then I want to find out the time. So a little bit of rearranging involved here. So I've done 0 equals 60. Plus, so I've just stuck in everything I know. Now, to get, because this is 0 on this side, this probably stumped you, I can minus 60 from both sides. Whenever you see like a plus or a minus, you sort these out first. So get rid of the 60. So if I take away 60 from both sides, I get minus 60 there. And then I'm left with 0.5 minus 0.5 times t. That becomes 0.5 t, okay, with a minus there, both minus. So this is going to come out to be a positive when it's a minus and minus. And then to get t on its own, I've divided both sides by 0.5. So when I divide this side by 0.5, this just goes to t. When I divide this side by 0.5, it goes minus 60 over minus 0.5. And that becomes, so my t becomes 120 seconds when I plug that into the calculator. If you need to watch that again, what I did, please do, because there's a lot of rearranging here. Let's go to the next example then. So example 3, a car accelerates, so it's not decelerating this time, from 10 to 30. So I've got my u, I've got my v, 5 seconds. What's the acceleration? Have a go at this one. So for example 3, I did the same thing again. I wrote out my known values. We're looking for acceleration this time. V equals u plus at, still using the same formula. I got 30 equals 10 plus 5a. Remember now we're taking the 10 away. So if I take 10 away from each side, 10 minus 10 is 0, so that becomes nothing. And then 30 minus 10 is going to be 20. So that now drops to 20 on this side because I've taken 10 away each side. And now for 20 equals 5a, to get a on its own, I divide both sides by 5 now. So this 5 drops down. 20 over 5 equals a, so a equals 4 meters per second squared because it's an acceleration. Okay, so the next question now, when we come to it, well, the next 2 questions, I should say, these are the ones that I want you to submit now on to Teams. So, I mean, we were doing last time the comments in the YouTube box, but then that's not very good because people can just copy answers there. I didn't really think of that at the time. So what I'd like you to do is to submit the work-ins. If you can get a bit of paper and you can write these down, okay? You don't have to submit the practice that we was doing, but these ones now I'd like to look at on Teams, okay? So if you can take a photo of it on your phone and then just send it through as an assignment, as part of the assignment. So question 1 here and then question 2, okay? Which brings us now to rule 2. So S, which is displacement, equals half, and then U plus V times T. This is written slightly different in our books, but we're going to keep with this way. Okay, we're going to keep this. So again, that's what they mean, and I think I even show you both ways on the next example. But let's have a look at the question. So the question is, a hamster in its ball starts at rest, and accelerates to 3 meters per second in 6 seconds. What was the distance the hamster traveled? Now, in your book, you got S equals U plus T over 2 times T. And because it's over 2, that's saying it's half. It's half of everything here. I don't know if you know from maths, but that T is going to, so U plus V is going to be times T. That's where that U plus V times T there. So this kind of T moves up a little, even though it's right in the middle on the line in your books. Okay, it's not the best, so this T would move up, U plus T times T. And then because it's 2, we could just say half. So it's a really simplified version of that. I'm going to show you how I did this question. So I'm going to show you the 2 that I did. Okay, so don't be panicked thinking you have to do all this. So the first thing I did was I identified all my values. So I've got my SUVAT, okay? We're not really dealing with acceleration here, and we want to find the distance, the displacement. So the first formula, which you'll find in your books, is S equals U plus T over 2, and then it's all times by T. So I filled in my values there. So my U was 0 because it came to rest, I think. And then plus 3 was my final velocity, over 2 times 6, which was my time. And then I worked that out, so I just worked 0 plus 3 is just 3 over 2 times 6, which came out to be 1.5 times 6, because 3 over 2 is 1.5, and then that came to be 4.5 meters. And then I did it this way, okay? And you'll see that it comes out exactly the same, because when I input my values, 0 plus 3 is still 3 there, times 6. So half of 3 is 1.5 times 6 is going to be 4.5, so it all works the same. Okay, so that was that one. Let's do another example. So this is example 2. I'd like you to have a go at this now using this equation. So you read the question, identify what you've got, have a go. So I've only used this equation now for this one, okay? So I've identified my values from this, which was 850 meters, at an initial velocity of 4. It went to 29, okay, which is quite fast. I think these questions was made up. And then we're looking for T. We're looking for T because we're not dealing with A in this one at all. So I've written out my equation, then I've started replacing the values. So 850 equals half. And then the brackets, 4 plus 29. We've got to do the brackets because of BODMAS or BIDMAS, whatever you use now. Because if you just type that all into the calculator without brackets, it would, it would really mess it up, because you have to do, you have to add these inside the brackets and then times it all. You couldn't say 4 plus 29 times that, because it just wouldn't work. So you need to do this. I'm sure you know this anyway. So 4 plus 29 is 33. Then you can times the 33 by T, but we don't know T. Okay, so I've halved the 33, because it's half times 33 there. So 16.5 T. And now to get T on its own, I divide both sides by 16.5. This comes down. 850 over 16.5 equals T, which comes out to be 51.5 seconds. Okay, hopefully you can see the method there. I think we've got another example coming up. Oh no, I'd like you to have a go now. So this question I'd like submitted, okay, on Teams. So this is called question 3. So this will go with your question 1 and your question 2. And this is your question 3. So have a go with this and submit it, please. So this brings us now to rule 3. So we're halfway there. So v squared, that should be, it's not v2, equals u squared plus 2as. And there's what they mean. Should be used to these by now. Let's do an example. So here we go, a man walking along, minding his own business at 1.5 meters per second. So that's his speed. And then some dog comes along, starts chasing him. and he accelerates to this, and he runs for this long, 30 meters. Okay, what is his new velocity? You could possibly have a go at this if I just rewrite that. So v2 equals u2 plus 2as. Make sure you write out what you know. Okay, and I'm sure at this point you could have a go at this. So this is what I got. Okay. So I identified all my values. So I got 3 values and an unknown value. My unknown value was the velocity, okay, because we're not dealing with time. Biggest challenge here is because I got v squared, and it's wrapped up in a v squared. So to get v on its own, I have to use the square root. So I've did my method where 1.5 squared, because it's u squared, so 1.5 squared plus 2 times 0.5 plus times 30, sorry. So 2 times 0.5 is 1, so that's just 1 times 30. So 2.25, which was that, plus my 30, it's going to give me 32.25. So my v squared then, to get v on its own, I need to take the square root of this side. Okay, so to get v squared on its own, I need to do the square root of v squared to get v. So I have to do it to this side as well. So 32.25 inside there, which comes out to v equals 5.7 meters per second there. Okay. That's the hardest bit of this one. So if you got down to this point, don't forget these questions are worth sort of 4 marks. And if you can get down to this point, you know, you've earned the majority of the marks anyway, just by showing that you know the process. Here's another example you can try. So do the SUVAT and just follow this method out. V squared equals u squared plus 2as. Lovely. Okay, so we got 100 meters. We've got initial velocity of 30, final velocity of 0 there. Okay, don't you go that far. So v squared is going to become 0 now. So this is where it becomes a bit easier, because you've got 0 on this side. So 0 squared, which we all know is 0, but we'll get there in a minute, equals 30 squared. Now, if you haven't got a scientific calculator at home, what I'll do is 30 times 30, and that's going to give you your answer, okay? Remember, squared is just that number times itself. Plus your 2 times 100a. I've kind of swapped those, okay, to, instead of saying a 100, I've said 100a. That's all I've done there. So 0 equals 900 now, which is 30 squared, plus, and I've worked that out, 2 times 100 is 200a. Need to get 900 on this side now, because it's a plus there, so you can do that, just subtract 900 for both sides. So that becomes minus a 900, which makes sense because it's deceleration, getting slower. Okay, so you're going to have a minus value. And then to get 200, to get a on its own, you just divide both sides by 200. Hopefully this is becoming more familiar now as we keep doing this, which equals a. So a becomes minus 4.5 meters per second squared. This is a deceleration, so that's right. Okay, because you only got a minus on top and a positive on the bottom. If it was minus and minus, they would become positive. The same when you times a minus and a minus, when you multiply. Got one more example here, because these are quite difficult ones. So have a go at this, and then the question will follow this one then. Okay, so I think this is our last practice. So I've done my SUVAT. The method is the same every time. Every time. So I've written out my equation. And again, we've got a 0 here for final velocity, which makes it easier. I've got my u to be 25, so that's 25 squared there, plus my 2 from there, times 1.47, which was my a. And then s. Okay, you just got to be careful now. That's not seconds. That is your s. That's the only. I guess that's why they change it to x vat, because this is an x sometimes. But I know what that means. So it's my displacement. So 0 squared is just 0 equals 625. That was 25 squared plus 2.94, which was 2 times that. Okay, s. I'm going to get rid of the 625 by minusing it. So by subtracting it each side. So I've got a minus 6.25 now. That disappears. I've just got 2.94 s. I need to get s on its own, so I need to divide both sides by 2.94. So minus 6.25 over 2.94 gives me 213 meters. And again, that would be A minus because it was minus 6.5 because it's deceleration. It's going back in the other way. So I just forgot my little minus there. And because it's the displacement, you can have a negative. Okay, if this was just a distance, you couldn't have a negative because you can't have a negative distance, but you can with a displacement because displacement is a vector. Okay, it's got magnitude and direction. And I'd like you to have a go at that because this is a very common one that comes up in the exam. So I'd like you to practice 3 questions here. Well, not practice, submit. So this is what you're going to submit on Teams. Question 4, question 5, question 6. Have a go at them all. I'd like to see something, okay? Because it's only, even if you're making mistakes, I can see the mistakes that's being made then. So that helps me. Okay, and this is our last rule now, and it's quite an easy one, this, I find, even though it looks hard. This is where the word SUVAT comes from, because that kind of looks like SUVAT. So you've got S equals U times T plus your half AT squared there. So let's have a go. I think I've only got one example for this, because it's quite easy. So here's the example. Have a read of that, have a practice, see what you get, and then you can look at my answer on the next slide now. So here's my answer. I've written out what I know. I've got 3 known quantities, and I'm looking for S. Okay. Find the distance. Well, I should say displacement really. Traveled by the cyclist in the first 20 seconds. So I've written my equation out. Even though it's a long equation, it's quite an easy equation. So S equals 0 times 20, which we all know is going to be 0 anyway, plus half of 0.4 times 20 squared. So 20 squared, I just did in my calculator, 20 times 20, which is 400, 0.4, 0.5, and then my 0 there. And once you can just, because that's a 0 now, it is essentially in your calculator 0.5 times 0.4 times 400 comes out to be 80 meters. So I think this equation is probably the easiest to use, which is why I'm going to give you the question next. So this is your last question now. Question 7. This is what I'd like submitted. And this is what you got. You're looking for distance there. Okay, thank you very much for listening. I hope you're having a nice day, and I will catch up with you at some point next week. Okay, good luck.